Welcome to Spring LIB.
Well, in an elliptic orbit, the total system energy is conserved and energy remains the same. So U is equal to K, which is kinetic energy plus gravitational potential energy plus internal energy is equal to K. Well, K is a constant. The velocity is not uniform, however, and the satellite slows down, losing kinetic energy at the farthest position from the Earth on the trajectory. And conversely, the satellite speeds up as it closes the radial distance to Earth. So, any loss or gain in the system's kinetic energy is counterbalanced by the change in system's gravitational potential energy. So in general, for an elliptic orbit, uh, initial kinetic energy is not equal to final kinetic energy, and also initial gravitational potential energy is not equal to final gravitational potential energy. But the total energy is always a constant. So if we examine the equation for the gravitational potential of the system, well, initial gravitational potential energy is given by minus capital G, well, capital G is the gravitational constant, times mass of Earth times mass of satellite divided by the radius. Well, the negative sign associated with this potential energy becomes important in the energy balance enforced by conservation of energy. Well, it is because the radial distance grows large at the most extreme points on the elliptic trajectory, and because of the sense negative, the gravitational potential energy becomes less negative at these points. This is equivalent to increasing. This also helps explain why the kinetic energy can reduce at these extreme positions and then speed up again as the satellite nears Earth without any external systems required. So let me draw an elliptic orbit here, and let's say this is the Earth, and this is the point which is closest to the Earth, and this is the farthest. So at this point, the kinetic energy, let's say this is A and this is B. At point A, kinetic energy is, let's say, Ki, and at point B, or we can say Ka, and at point B, kinetic energy is Kb. Well, kinetic energy at point A is greater than kinetic energy at point B. Well, since the satellite when it is near the Earth, it speeds up, therefore its kinetic energy is higher at point A than at point B. But when it comes to gravitational potential energy, well, let's say gravitational potential energy at P is UB and at A is UA. So gravitational potential energy at point B is greater than gravitational potential energy at point A. But the total energy, the sum of kinetic energy and potential energy at any point on the elliptical orbit is always a constant.